number one. So the only thing is this gives you extra options. So I would make sure you think about it really hard because you can't use process of elimination. So it says given P to Q is the same as R to S. That's going to be given. They give us that. The next step to tie this step to this step, the part that is changing is that it is changing from a congruency symbol to an equal sign. When you change your symbol from an equal sign to a congruency symbol, that is automatically going to be a definition of congruence. Because when the sign changes and everything else is the same, flip-flops equals to congruence, it's definition of congruence. The next step says P to Q plus Q to R equals P to R. Notice they're all together. It's one little section. The other one says Q to R, so I'll use the other side. Q to R plus R to S is this whole other little section. So it's section together, they're right next to each other. This piece is together, this piece is together. So that is segment addition property. Then it says RS plus QR equals PR. If you tie the last step to this step, if you notice, the only thing that's really changing, they don't even use this back half. They don't even use this part. This is identical to this. The only thing that's changing, this is the same, this is the same, this is changing. So whenever I'm taking something and I'm changing that piece only in the problem, that's because I know PQ is equal to RS, so I can change PQ to RS using substitution property. The next one we technically, I don't think we've talked about, but QR plus RS, they just flip it. So when it switches, it's kind of like simplifying commutative property, it's just rearranging it. The next one says QS equals PR. So if you notice, PR has stayed the same. The part that is changing is the QS. This has combined to make QS. If I look for the same thing, that's different. This right here, QR plus RS is QS. So we're crossing off what's the same, and we're plugging in or setting these two equal to each other. So QS is equal to PR. That is transitive property. And then symmetric, it flips it. And then when the equal sign changes to a congruency symbol, that is definition of congruence because the symbol changes again. Number two says that she's building a gate following this diagram. If the measure of LMN, this corner right here is 43. And I know LMN is congruent to OMP. These are both 43, because if one's 43, the other one's automatically going to be 43 as well. I need to find NMP. NMP is this piece right there in the middle. So if I think about this, and if I cover up all the rectangles, because it's kind of confusing with the little rectangles, it's literally just making a straight line. So together, all three of these angles make half of a circle. Half of a circle or a straight line is 180 degrees. So if my total is 180 and I know each side is 43, I'm just taking 180 and I'm minusing 43 2 times, which gets me 94 degrees because they have to form a straight line together. For question 3, it says C is the midpoint of AB. So when in doubt, let's draw it out. So I have A to B. C is in the middle. So I know whatever is over here is also over here. They are congruent. And B is between A and D. So I actually have 4 points. So B is also between A and D. So D is somewhere over here because B is between them. So I'm going to extend it just a little bit and I'm put D. So if AD is 22, and BD is 6, I need to figure out what C to D is. So I need to find this section here. Now, because I know these two pieces are the same, they are congruent because it's a midpoint, I can call both of these that I don't know X. So I can put a little X here, and I have a little X here. They're the same because C is the midpoint of AB. I also know B is between A and D. B to D is 6. The whole thing is 22. So I'm doing piece plus piece plus piece equals whole. So this is segment addition property. So X plus 6 equals 22. If I combine like terms, X plus X is 2X. I'm adding 6 and it equals 22. I'm gonna minus 6 from both sides. And I'm dividing by 2. So that means that this is 8. This is also 8. I need to know the length of C to D. Which is 8 plus 6. Which is 14. Okay. Next one is technically a review problem. It says if EF is perpendicular, which means 90 to FH, then EFG is 2x plus 1. GFH is 3x minus 6. I need to find the measure of EFG. So I have to plug it back into this one. I know together they make 90 because they're telling me they are perpendicular. So I'm doing angle plus angle equals 90. I'm going to combine like terms. 2 and 3 make 5x. 1 and negative 6 make negative 5. I'm going to add 5 to both sides because opposite operations. And then I just divide by 5. So x equals 19. So if x is 19, I'm plugging it back into EFG. So I'm doing 2 times 19, and I'm adding 1. So 39 degrees. For the next one, it says if RS is 7 and RT is 18, ST is 11, points RS and T are collinear, what's the relationship between RS and T? We basically need to figure out which one is in the middle. If I think about this, the longest segment is RT. So R and T would have to be on the outsides because it's the longest. So if R and T are on the outsides and you only have 3 points, you have R, S, and T. The one that would have to go in the middle would be S. So S would have to be between R and T. So I think you should just pick the longest one. Whatever letter's not in the longest segment is the missing one that's in the middle. So S is between R and T. For the next one, you have 3 statements. We are using this paper from 3.1, which is conditional, converse, inverse, contrapositive, biconditional. It's rearranging your sentences. So it says if 3 points are non-collinear, this is P, then the points define a plane. That's cute. So it says if the points define a plane, so notice that the back is now the front, then the points are non-collinear. So they flipped it. So if I look at my options, if I flip the sentence, the original is P to Q, now it's Q to P. Q to P is going to be a converse. So the answer for this one is B. So going back to the original, P and Q, it says if 3 points are collinear, so P is still in the front. The only thing that changed is it said non, now it does not. So this is negative, it's negating the sentence. Then the points do not define a plane. So this is still Q, Q is still in the back. Instead of it being this, they're adding the word not. So they're making it a negative sentence. So they did not flip it, they just made it negative. So that's going to be your inverse. You're making it negative. And then the last one uses, it says if 3 points do not define a line. So that's the back half, and it's making it negative. 3 points do not define a plane. Not is negative. Then the 3 points are collinear. That's the front half. So they flipped it and they made it negative. So flipping it and making it negative is going to be your contrapositive. Seven says, if possible, write it as a biconditional. Biconditional is the nice one. It always uses the words P, if, and only if Q. So our statements are vertical angles are congruent. I'm making a biconditional statement, so I need to use if and only if smack dab in the middle. So if I look, the only one that uses if and only if for biconditional is C. 8 says, given the measure of angle 1 plus the measure of angle 2 is 180, which statement is always true. If they add to make 180, they could be adjacent, but they don't have to be. They could be a linear pair, but they don't have to be. The only thing if they add to make 180 is they are definitely supplementary. They could be right angles separately to make 90 and 90 to make 180, but they don't have to be 90. One could be 40 and one could be 120 or 140 to make 180. Number 9 says what is a counterexample for the conjecture? So we're looking for a counterexample. So the statement is false. We need to prove why it's false. We need to use an example to prove that it's false. So if 2 angles have a common vertex, they are adjacent. So what they're saying is your angle, if they share a common vertex, which is a corner, they always have to be adjacent. They always have to be next to each other. This is your vertex. They're next to each other. That's a false statement. They could share a point. They could share a vertex, but not be adjacent. So we're looking for something like that. So 2 angles that are a linear pair. Linear pair is a straight line that adds to make 180. They still share a vertex. They are still adjacent. So that's not a counterexample. This is that could happen. 2 angles are vertical angles. So if they share a common vertex and they are vertical, these are not adjacent because it would be this angle and this angle. They do not share a common side. So that is my correct answer. The next one says 2 angles that are supplementary. That's not true because they could be like floating around, but that also means they don't share a vertex. So that's not going to work. Two angles that are complementary, same thing. They got to add to make 180 or 90. So they could have several vertexes, but they're still not adjacent. So that's like false, false. This one's true, true, but we're trying to find something that's true and false. So they are share vertex, which is true, but they're not adjacent. So that's my counterexample. 10 says if statement ones are they're true conditional statements. If figure A is a parallelogram, then it's a quadrilateral. If figure A is a quadrilateral, then the sum is 360. What conclusion is valid? So this is where you look at what they have in common. They have in common the quadrilateral part, so I can remove that and I can set these two pieces equal to each other. So if a figure is a parallelogram, then its angle sum to 360, which would be D.